Today in the workshop, we're checking out some artificial intelligence cameras. You'll see how AI cameras work and how to use them with a Raspberry Pi. We'll also compare the ArduCam PiNSIGHT with the Raspberry Pi AI camera to see how they differ. It's an intelligent picture today, so welcome to the workshop. Well, hello and welcome to the workshop, and today we're going to be working with a couple of really cool edge computing devices, some AI or artificial intelligence cameras. Now, you're hearing the moniker AI applied to just about everything these days. It's everyone's favorite buzzword, and you might wonder what an AI camera is. Is this something newfangled that hasn't been on the market before? Well, in some ways, yes, and in some ways, no. We've had intelligent cameras for many, many years now. In fact, here in the workshop, we've worked with things like the DF Robot Husky lens, which is a camera that could do object detection, etc. And also way back, we worked with something called the PiXiCam that had similar capabilities. Now, the cameras we're going to look at today are dedicated to the Raspberry Pi, and they work a bit differently than the cameras we looked at before. With these cameras, you upload a neural network model to the camera itself, and then the camera performs all of the AI processing functions, leaving the Raspberry Pi free to do whatever else you want the Raspberry Pi to do. So this is a really exciting new category of sensor, and I'm happy to take a look at two of them today. One of them from ArduCam and another one from Raspberry Pi themselves. So before we get started, let's learn a little bit about AI or artificial intelligence cameras. AI cameras are more than just regular cameras. Their internal intelligence gives them a number of additional abilities. Computer vision is the ability to interpret and understand visual data from images and video. AI cameras are capable of machine learning. They can learn from data and improve their performance over time. Deep learning is a subset of machine learning, and it uses neural networks to analyze data. And AI cameras are capable of image processing, where they enhance, filter, and manipulate images in real time. Artificial intelligence cameras have a number of uses, including object detection to identify and track objects within a scene, facial recognition to identify and verify individuals based upon their facial features, gesture analysis interprets human gestures and movements, and image classification allows you to classify images into predefined categories. While you can use a standard camera for artificial intelligence, AI cameras have a big advantage, and they operate in a different fashion. With a standard camera, the camera provides the images only. A Raspberry Pi would be required to perform all of the AI functions. In this case, the results will depend upon the performance of the Raspberry Pi. With a standard camera, the Pi resources are used extensively, leaving little resources left for other processing tasks. An AI camera, on the other hand, provides both images and AI results to the Raspberry Pi. In this scenario, the camera performs all the AI functions. The results, therefore, depend upon the camera's performance and not the Raspberry Pi's. With an AI camera, the Pi resources are used sparingly, allowing the Raspberry Pi to perform other functions or allowing you to use a less powerful Raspberry Pi board. The AI cameras we'll be working with today work as follows. First, we need to send an AI model to the camera. That model will get loaded into the camera's memory. And with the model loaded, the camera can now return video and AI data directly to the Raspberry Pi. Today we'll be exploring two different AI cameras, the Raspberry Pi AI camera and the ArduCam PiNSIGHT AI camera. So let's go take a look at them. And here are our two artificial intelligence cameras, the ArduCam PiNSIGHT camera and the Raspberry Pi AI camera. And you couldn't have two items that performed the same function and looked more different than these two. Now, the ArduCam camera actually looks like an old-fashioned digital camera from back at the turn of the century, basically just a rectangular box. And on the bottom of it, you can see that they have got a thread for a tripod. I really love that. That's one of my favorite features of the camera. If we flip it over, you can see a couple of mounting threads, and these, of course, are sized out for a Raspberry Pi. So if I place a Raspberry Pi onto it, I can mount it directly to the camera and make one complete unit. And the only connection I need to make would be to the USB, which is over here. Now, the Raspberry Pi camera, on the other hand, looks like any other Raspberry Pi camera. It's a tiny little module, with the exception of it being a bit thicker than the standard Raspberry Pi camera. It's identical. It'll mount in the same mounting holes. On the back over here, you can see we've got the connector, and that's the connector for the flat CSI cable that connects it directly to the Raspberry Pi board. So two very different looking devices that perform similar functions. Okay, so let's get going by taking a look at the first camera that we'll be reviewing today, and that's the Raspberry Pi AI camera. Now, the Raspberry Pi AI camera looks quite a bit like the standard Raspberry Pi camera. It'll mount in exactly the same mounting holes. It's a bit thicker because it has a few extra components on it, so if your case requires the Pi camera to be a certain thickness, you're going to want to adjust it for this, but otherwise, you can use it as a direct replacement. It connects to the Raspberry Pi in the same fashion, and it's pretty easy to use, as you're going to see when we take a look at the Raspberry Pi AI camera. The Raspberry Pi AI camera is based upon the Sony IMX500 video sensor. The IMX500 is the world's first video sensor that has both image and AI processing on the same chip. There's an onboard digital signal processor and 8 megabytes of static RAM. The sensor has a resolution of 4056 by 3040, and it's a 12.3 megapixel device. The raw sensor is capable of 4K video at 60 frames per second, or HD video at 240 frames per second, but it should be noted that you won't achieve this performance with a Raspberry Pi. The IMX500 can output full video plus AI processing at 30 frames per second. The device outputs AI metadata along with the video. The IMX500 also has support for TensorFlow Lite, a light version of the TensorFlow machine language application. The camera specs are as follows. It has the Sony IMX500 12.3 megapixel sensor, a 78.3 degree field of view. The focus is manually adjustable, and a focus adjustment tool is included in the package. The camera also uses a Raspberry Pi RP2040 microcontroller as a neural network manager, and I'll speak more about that in a few moments. The Raspberry Pi AI camera has a standard Raspberry Pi camera connector. For this reason, the AI camera is compatible with all Raspberry Pi computers. It uses the standard Pi camera mounting holes and has the same dimensions, although you should note that this is a thicker device, so some cases may need to be modified for it. The AI camera is packaged with two 200mm camera cables, one with the standard connector and one with the mini connector for the Raspberry Pi 5 and 0. Internally, the IMX500 consists of a video sensor, an image signal processor or ISP, and a neural processing unit or NPU. The video sensor outputs high-resolution video. The ISP converts that video signal to a lower resolution, anywhere from 640 by 480 down to 64 by 48. The output of this goes to the NPU, and this is called the input tensor. The NPU processes the tensor and produces an output tensor. That output tensor is sent to the Raspberry Pi via the CSI-2 camera cable. Now here's how the RP2040 microcontroller factors into the camera. AI firmware is sent from the Raspberry Pi to the RP2040. That firmware is then transferred to a 16 megabyte flash memory chip on the Raspberry Pi AI camera. It's then used to load the 8 megabyte static RAM on the IMX500. This arrangement has several advantages. First, the RP2040 can manage the data better than the IMX500 can and avoids multiple I2C calls back to the Raspberry Pi. Secondly, the memory on the RP2040 is flash and is thus non-volatile as opposed to the volatile memory on the IMX500 sensor. The Raspberry Pi AI camera retails for $70 US. It's available at all Raspberry Pi dealers. It supports the rpicam-apps application. It also supports Pi Camera 2, so you can use your Python programs with the Raspberry Pi AI camera. So now let's go and take a look at this amazing little camera module. And here's the test setup that I'll be using with the Raspberry Pi AI camera. Now, as you can see, I've simply got the Pi AI camera plugged into one of the CSI camera connections. And I've got it mounted up on a homemade mount, something I made out of a piece of perf board and an old GoPro adapter. And this just allows me to put it onto any standard 1/4-inch tripod. I've got a really cheap little desktop tripod that it's standing on right now. And that's basically the setup. It's a very easy thing to set up and get going. So now that I've got it hooked up to the Raspberry Pi, let's see what we need to do in terms of software to make it work. And so we're going to get started with the Raspberry Pi AI camera, and we're going to open up a terminal and type in a number of commands. And to make our lives easier, I've created a cheat sheet. Now, those of you who've seen a few of my videos might be familiar with this. It's just a text file that has all of the different commands that we're going to need to type into the terminal. It's a lot easier just to copy and paste them. And I've got a cheat sheet for both the Raspberry Pi AI camera and for the ArduCam PiNSIGHT camera, and you can download these cheat sheets off of the article on the DroneBotWorkshop.com website, the article that accompanies this video. So get your own cheat sheet and avoid a lot of typing. So the first thing we're going to do is we're going to just update the Raspberry Pi, and that's really important to make certain that we are at the latest, greatest version of the software. We're going to do that for both cameras, so we're going to start off by doing that right now. And we'll say yes, we want to install the updates, and we'll let that install. And of course, depending upon the status of your Raspberry Pi operating system, this may or may not take a bit of time. So I'll meet you back here when we finish our updates. Okay, now our system is updated and we can move on to the next command. And this command installs all of the Sony IMX500 firmware. It does quite a bit, this command. It actually installs the firmware pack. It installs the neural network models. It modifies the rpicam-apps application, and we're going to be taking a look at that, so it has some parameters that can use the AI camera. And it also installs the Sony network model packing tools, and that allows you to package up new neural network models for the camera. So there's quite a bit that's going to happen with this command. Let's go and run it right now. And we'll say yes. And once again, this is going to take quite a bit of time to install, so we'll let it go and do its thing, and I'll meet you back here. And so now we've installed all the files we need for the IMX500 camera module. The only thing left to do is to reboot the Raspberry Pi, which you can do in the conventional fashion, but since you have the terminal open, you may as well do it down at the terminal with a sudo reboot. And so now we've installed all of the files for the IMX500 and we've rebooted the Raspberry Pi, and we're ready to begin testing our Raspberry Pi AI camera. So we can go back to the cheat sheet and we can see that we've got a demonstration using rpicam. And if you recall, the files we just installed also modified rpicam to take a post-processing file. Now rpicam hello/t0 seconds is a pretty standard command I'm sure you've probably run before if you've used the Raspberry Pi camera. This just opens up a video window, and it'll open it up indefinitely if you give it a time period of 0 seconds. We're going to add a post-process file to it now, and the file we're going to add is this one over here, imxmobilenet.ssd.json. And a mobile net is what's called a convolutional neural network. It's a small neural network, and mobile net is made specifically for edge computing devices, so it's very small and fast. An SSD is a single-shot multi-box detector, and that's a technique that is used to divide the screen up into a series of boxes and then work on each individual box to determine what's in it. So it's a very fast detection technique. So we're going to add that to rpicam hello. So let's just copy that and go up to here and paste it in. And we've got a screen with my torso in it, and it can see me as being a person, which is really good because I am a person, so it does seem to work with a bounding box around a person. Now, I don't have a lot of interesting stuff here in the workshop that it seems to be able to tag on to. A person is about the only thing. Sometimes it'll pick something up as a video monitor, but it seems to work very quickly and very well. And remember, this is all being done up on the Raspberry Pi AI camera. The Pi itself is not doing any of this. So this is very fast and will be very fast with any Raspberry Pi board that you use it with. Now, when you're finished looking at my torso, you can do a Control-C down here in the terminal screen, and that will end everything. Now we're going to do another demonstration with rpicam-app, and in this case the post-process file is going to something called PoseNet, and this is going to do pose detection. So we can copy that and put it into our terminal. And it loads it up to the camera. And I need to step back a bit from the camera here. You can start to see this. It's detecting my pose. And it's actually doing a pretty good job of it. It's very, very quick to respond to every movement I make. And so there's another thing, another demonstration that you can do with the Raspberry Pi AI camera, And once again, this of course is happening all up in the camera. The Raspberry Pi isn't getting involved in this, and it can just be left alone to decide what to actually do with that posing data. So up until this point, we've been using rpicam to demonstrate the operation of the AI camera, but you can also use PiCamera 2. And the big deal about using PiCamera 2 is that you can call PiCamera 2 from within your Python program. So you can use the data from the AI camera directly in your programs by making use of PiCamera 2. Now, before we do that, we need to install a couple of things. The first thing that we want to install is OpenCV, which is an open computer video library that needs to be installed for Python 3, and also the MonkRes algorithm. This is also called the Hungarian algorithm, and it's a sorting algorithm. So we're going to need to do that with this command over here. We'll take this out of our cheat sheet and place it down into our terminal. And we'll say yes to that, and we'll do the installation. Okay, now we've got the OpenCV dependencies and MonkRes installed. The next thing we want to do is run PiCamera 2, and we can get a lot of good sample code from the GitHub PiCamera 2 repository. And what we're going to do is just clone that to our machine. So let's just do that. And this will take a few moments to download everything, and once it does, we'll have a couple of example files that we can run. Okay, so now that we got the PiCamera 2 files downloaded, we can go into the examples directory and take a look at the examples that come included with it. And so we've got the command over here to change to the folder with the examples. We'll just put that in. And we'll do an ls. And you can see we've got a number of different examples. Just let me raise the screen up so you can see it a bit better here. Object detection demo, classification demo, pose estimation, a lot of different things. Let's go and run one of these demos now. Now we're going to do the object detection demo, and you'll note that we put a number of parameters behind it, and the parameter is the mobile net SSD is what we're going to be using. So let's give this a whirl. And you'll note you get a bar graph showing you the firmware upload to the camera, and there we go. And it's detecting an object, and that object is indeed a person, and I'm pretty sure that is a person. So it's working just as it did earlier with the rpicam app, except this time we're using PiCamera 2. So this is available to us within our Python program. So if you're going to do a robotics project or some kind of object detection project, this is what you would use. And there's another couple of examples over here that you can run. The documentation on the article in the DroneBotWorkshop.com website will help you along with those. Now, the ArduCam PiNSIGHT looks quite a bit different than the Raspberry Pi AI camera, but it performs essentially the same functions. It can take an AI model, a neural network model, and process it on board with the camera. Unlike the Raspberry Pi camera, this is a completely self-enclosed unit that uses a USB-C connection, and it's got a lot of interesting features. So let's take a look at the ArduCam PiNSIGHT AI camera. The ArduCam PiNSIGHT is a self-contained artificial intelligence camera. It uses a USB-C interface for both data and power connections. The camera has a 12.3 megapixel sensor and is capable of 4K video at 30 frames per second. This is an autofocus camera with a range of 15 centimeters to infinity. The camera also has an integral infrared filter. The PiNSIGHT can be used for many AI applications. One common application is face recognition. Fatigue detection is an important occupational safety application. Object detection is a pretty common AI function. Anomaly detection can be used in a production line to detect defects. And pose estimation is another very common AI camera operation. Internally, the PiNSIGHT uses the Luxonis OAK-SOM Artificial Intelligence Vision Module. This module can run at up to 4 TOPS or tera operations per second. The module is based on the Intel Myriad X Vision Processing Unit, and indeed when it's connected to a USB port it identifies itself as a Myriad X. The PiNSIGHT can run many of Luxonis's depthai models, and several of these are included as examples. It can also run Intel's OpenVINO deep learning product. The ArduCam PiNSIGHT mounts on the bottom of the Raspberry Pi board, and hardware is included to attach it to the camera. Connection of the camera is very simple. Using the supplied USB-C cable, one end is connected to the Raspberry Pi USB 3.1 jack. Make certain you use one of the blue jacks, as the white ones are not USB 3.1. The other end of the cable simply connects to the PiNSIGHT's USB-C connection. The ArduCam PiNSIGHT has a standard 1/4 inch tripod mount for easy mounting. It requires USB-C power of 5 volts at up to 1 ampere. And the PiNSIGHT retails for $99.99 US. So now let's take a look at the ArduCam PiNSIGHT. And here's the installation I've made of the ArduCam PiNSIGHT camera. Now note that although the PiNSIGHT camera is designed to be mounted directly to the Raspberry Pi, I just chose to connect it remotely to the Pi and put it up on a tripod, which of course is very easy to do since it has a 1/4 inch thread already in the camera. Otherwise it's pretty simple. It just connects with a USB-C cable that needs to go to one of the USB 3.1 jacks on the back of the Raspberry Pi, and that's one of the blue jacks. So as long as you plug it into one of those 2 jacks, that's basically the installation. So a very easy camera to set up. Now let's go and see what software we need in order to make use of it. Okay, so as with the Raspberry Pi AI camera, I have some software I need to install in order to run the ArduCam PiNSIGHT camera, which I have connected up to my Raspberry Pi now. Now, once again, I'm using my cheat sheet, and once again, the first command in the cheat sheet is to do an update and full upgrade. So I've already done that, and I'm down to the second command, and what we're going to do is get an installation script for the PiNSIGHT camera. So let's just copy that. Paste that in and give it an enter. And we've got our script. And so the next thing we want to do is make that script executable. And we can do that over here with a chmod. And we've done that. You don't get anything back when you do a chmod. And now we can actually run our installation script now that it is executable. And we're going to let that run for a while and install all of the software. Okay, so now all of the ArduCam PiNSIGHT files have been installed, and one last thing we can do, as we can see in the cheat sheet, is to verify the installation with an LSUSB. And like the ls command will list all of the files and folders, LSUSB will list all of the USB devices. And we just want to see if we have our Pinterest camera connected. And so we'll do that, and we have it over here. It's an Intel Mobius is what we're actually looking for, and it's right over here. And so this is our camera, and so now that proves that we have the camera. And so the next thing we're going to do is take a look at what we've just installed. And if we do an ls, we will see we've got a couple of folders here we didn't have before, specifically depthai and depthai Python. And so we can go and take a look at an example in the depthai folder. So let's change to that folder, and we'll list in here. And we have a number of different files here that we can try, but there's a depthai, demo.py file here that we can give a whirl. And we'll hit enter over here. And it's got to load everything up to the camera. The camera makes a clicking sound when it starts to load data. That's something I've observed with this camera. And it actually opens up two different windows here where you can see my torso right now. It seems to be clicking in on something it thinks it's a TV monitor. It's actually mistaken about that, but let's just see over here. It's got me bounded. Okay, it does see me as a person. It says it's 100%. I'm a person. Hello. It's picking up some things that it says are TV monitors. They actually aren't TV monitors. But what the two screens are is this is the input screen that is actually going into the AI processing in the camera. And this is what the camera itself sees. So you notice it squishes the screen down a little bit, and it puts these bounding boxes over it. And you can give this a try, see what it can detect. And it works in a similar fashion to what we saw with the Raspberry Pi camera. Now, one thing I should mention is that when you're finished running the demo, and this applies to almost any demo here, you'll need to hit Control-C, and in this case, you'll need to hit Control-C twice to exit everything. If you try to close one of those video windows, it'll just open back up on you. So I've done that, and I've gone back down to my root directory, my home directory, that is, and I'm taking a look at the files inside the depthai Python examples folder, and you can see there's a number of different examples over here that you can try with the camera. Now, I should warn you that not all of these will work with the ArduCam PiNSIGHT camera. The reason is that these are provided by Luxonis. These have really nothing to do with ArduCam, and they're for a variety of cameras. So, for example, we have things like stereo depth. That will not work because you need a stereo camera, for example. But some of these will indeed work, and in most cases, they have a main.py file, and that's all you need to do is run main.py. Now, there are a few over here that look very interesting. The ability to get April tags, to track objects, etc. Again, I'd urge you to try some of these and see if they'll work with the camera. But I've found another repository of files that Luxonis has that's even more extensive than this, and I want to add this because this will really give me a number of different examples. And what we're going to do is we're going to clone it from GitHub. I've got the command here in our cheat sheet. So we'll copy this, paste it into here. And this is going to take some time. There are a lot of objects here. There's about 1.5 gigabytes of stuff that we're going to be downloading. So give yourself a bit of time to download it, and then we'll take a look and see what's inside this folder. So now that our big download is finished, we will now have a depthai experiments folder on our Raspberry Pi, and this has a lot of good stuff in it. Let's go into that folder. And if we take a look at what's in the folder, you'll see there's a lot of stuff here. Look at that. There's a lot of examples over here that you can try. Now, once again, these are made by Luxonis. Not every one of these examples will work with the ArduCam camera, but many of them will. And I'm going to try one over here, this OCR example that we have. They all basically run the same way. Now, I don't want this in my... Okay, let's move into the folder. And we'll take a look. And in most of the folders, what you're going to find is that there is a main.py file that you can run. And so all you have to do is Python main.py. And this leads to load again to the camera, which it's doing right now. And it opens up, and there's actually two windows that open up over here. Plus, I want you to also take a look at the screen. So let me just set everything up so we can kind of sort of see it. We don't want that there. And I'll get something for us to read. And I've got a recipe over here. So if you look in my terminal there, you'll see that what's being highlighted is being displayed on the terminal. It's showing the place on the screen that it is. It's a little out of focus right now. I bet it would do a better job if it was in focus. Maybe I should move it back a bit. I think that's better. And there you go. So it's got an optical character reader, and I'm sure if I was a little better at positioning my characters, it would work a little bit better. Once again, if you want to kill it, you'll need to do Control-C. And you can get back to here. And so there's a lot of stuff to experiment with. It should keep you pretty busy and find out some interesting applications that you can do with your ArduCam PiNSIGHT camera. Okay, so now that I've played around with both of these cameras, I wanted to offer my opinion on both cameras. It might be helpful if you're trying to decide which one is the right camera for you. Now, first of all, you can't really compare these cameras directly. Although they do essentially the same thing, they are indeed two very different products. One is just a camera module. The other one is basically a complete self-contained camera. So it's kind of like comparing a truck and a car. They can both do the same things, but for certain purposes, one is better than the other. Now, if we want to compare on specifications, that's a bit difficult, especially because Sony hasn't released very many specifications on the IMX500 module that the Raspberry Pi camera is based upon. We do know the ratings of the Luxonis module that the ArduCam camera is based upon, and it's got a rating of 4 tera operations per second, or 4 tops. There is no equivalent rating to reference for the Sony IMX modules NPUs, so it's hard to say. In practice, they both seem to detect things very, very quickly. They both were capable of detecting me as a person. Neither one could detect a multimeter. They both thought it was a phone, but to be fair, they were not loaded modules in which they would have seen a multimeter before. Now, to compare them on price, there's a real winner over there. Obviously, the Raspberry Pi camera is $30 less. However, again, it's a module. It is fixed focus, whereas the ArduCam device is autofocus, and so that might make a difference to you as well and make the difference in the price difference. Availability, though, is another story. The Raspberry Pi camera was a very easy thing to purchase. I purchased both of these cameras, and the Raspberry Pi one, I just went to my normal Raspberry Pi dealer. In my case, that's in Ottawa. I'm in Montreal. 2 days later, I had my camera. Buying the ArduCam camera was another story. I couldn't find any local dealers that had that camera. Now, to be fair, I bought it a few months ago. There may be dealers now, but there weren't back then. I also couldn't find it at places like Mouser, or DigiKey. These are places I buy a lot of stuff from, and they do stock ArduCam products, but not this particular one. I ended up going directly to ArduCam's store to buy it, and it wasn't the greatest buying experience. The store itself was okay, but in the shipping options, they had an option for express shipping. $15 US. It didn't say anything about who was due the shipping or how much faster it would be, but I thought I'd go for it, and I added it to my order. Turned out it was shipped by FedEx, who didn't think $15 was enough to ship it, so they added another $27.50 US to it. And just when I thought I was finished with that, Canada Customs put another 42 Canadian dollars on top of it. The long and the short is it cost me almost as much as it would to purchase a Raspberry Pi camera to ship the ArduCam camera to me. Now, I'm in Canada. Your experience in the US or elsewhere may be different, and it may indeed be out to different vendors now, but I certainly found it a lot easier to pick up the Raspberry Pi camera than the ArduCam camera. And also, another thing you might want to compare these on is versatility, and that's really depends on what your application is. The ArduCam camera, being a self-contained unit with the 1/4-inch tripod mount thread, is great for setting up and everything. It's easy to mount, and the USB-C cable is very easy to route to places. You could use a longer, high-quality USB-C cable and keep the camera a fair distance from the Raspberry Pi. It's not quite as flexible with the Raspberry Pi camera. The flat ribbon cable that they use for the CSI2 connector is useful, but it's a little harder to conceal in places, etc. But then again, if you're putting it inside an enclosure, you might prefer the smaller Raspberry Pi module to the large ArduCam module, so it really depends what you want. But either way, either of these AI cameras would be great to experiment with. Now, finally, the last thing is software and support. Now, the software and support directly from both of these manufacturers, Raspberry Pi and ArduCam, is pretty minimal. It's a couple of wikis, but where the real support is with the manufacturers of the modules. Now, Luxonis, who manufacture the module that's in the ArduCam camera, have a variety of tools and things that you can use to create models to upload to the camera. They are made not specifically for this camera, though, and so as we've seen with some of the examples, they may or may not all work with this camera. Sony, on the other hand, has also got a number of tools for the IMX500, and some of them are specifically for the Raspberry Pi camera. They also have tutorials and videos for using the Raspberry Pi AI camera. So I think the support and documentation is going to be a bit better on the Raspberry Pi side. Also, Raspberry Pi has said they are committed to supporting this camera until at least January 2028. No word what ArduCam's support plans for the camera is going to be like. So take all of that into consideration when you're choosing an AI camera for yourself. Okay, well, that wraps up our look at our two AI cameras. I hope that you found it insightful and that you're just brimming with ideas for AI camera projects for your Raspberry Pi. Now, if you want some more information about these cameras, or if you'd like to grab those cheat sheets that I was using with the terminal, you can get all of that on the article that accompanies this video on the DroneBotWorkshop.com website. And there's a link to that article right below the video. While you're on the website, how about joining my newsletter? It's not a sales letter. It's just my way of letting you know what goes on here in the workshop. It's free to sign up for, and all I need is your email address. If you're willing to pick a username and give me your name as well as your email address, you can sign up for the DroneBot Workshop forum, where you'll find a bunch of like-minded individuals who love to talk about all things electronics, and it's free to join the forum. And finally, if you haven't yet, please subscribe to the YouTube channel. I make videos about microcontrollers, microcomputers, electronics, artificial intelligence, and all sorts of fun things like that. So if you enjoyed this video, I'm sure you'll enjoy my others. All you need to do to subscribe is click on that red subscribe button, and also click the bell notification. And as long as you've got notifications enabled on your web browser, you'll get notified every time that I make a new video. So until we meet the next time, please take good care of yourself, stay safe out there, and I will see you soon here in the DroneBot Workshop. Goodbye for now.